Okay, here we go, chapter 11. These are all the different areas that we're going to cover in chapter 11. It's all about three-dimensional figures. So we're going to be covering volume and surface area. So let's start with just being able to identify a three-dimensional figure. It'd be a lot easier if we were in the classroom and I was holding those figures up for you, but I'm not. So here we go. We'll do the best that we can. So we're going to be identifying prisms and pyramids first. Hopefully you recognize the difference. One of the main things about a prism is that it has two bases, and the bases are parallel from equal distance from each other, so we say they're parallel. Pyramids have one base and they come to a point. Prisms are made up of rectangular faces, and pyramids are made up of triangular faces because they got to come to a point. So think about that. Okay, so here we go. Identify that solid, and it says name the bases, faces, and edges. So let's grab a pen. So you're going to be naming the bases, faces, and edges of the figure. So when you look at this, can you recognize that it is not a pyramid and that indeed it is a prism? Because like I said to you, a prism has rectangular faces. This is not coming to a solid point. There are no triangles on here. So when I name the bases, this is a rectangular prism. When I name the bases, it's kind of hard because I don't know if the base is right here or if the base is the bottom and the top. So a rectangular prism, bases and faces are like the same thing. So when you name them, you just name them by their vertices. So you have to be able to count how many you have. So remember, you'll have two bases on a prism, and then however many sides you have, that tells you how many faces you have. So I have two bases and I have four faces, okay? Edges are right here. Edges connect vertice to vertice. So like GH is an edge, HJ is an edge, JN is an edge. And then vertices, just naming the points. So it looks like this. It has two parallel congruent bases that are rectangles. Again, you can't really identify which one's the bases. It could be anything. But you do know that it is a rectangular, not pyramid. It is a prism. You would have fixed that if you guys were in class. Then, when you name the faces and the bases, you name all of the pieces. So think about cutting that shape and laying it flat. And then you would name all of its pieces. So it has two bases and four faces. It doesn't matter which ones are the bases because they're not different than any of the faces. So you just lump your bases and your faces together in a rectangular prism. Then you have your edges. So your edges, remember, just connect vertice to vertice, and you have to name all of them. Think about it. You have four edges going around each base. So that means you have 8 edges for the bases, and then you have edges that go all the way around. There's 4 of them. So you have 4 here, and 4 in the center. So make sure you count them first. And then vertices, they're just the points, and you just list them. So pay attention to edges, need to have line segments over the top. Faces, you just put the letters together, so that it creates. It doesn't matter the order either. I could go GLPK or I could go KPLG. I just can't go GPKL. So follow the line segments when you name the bases and the faces. So if you notice, this one comes to a point and it has triangular faces. So if you look at it, you always name it by its base. And in this case, the base is a triangle. So you will call this a triangular pyramid. So right here, it's called a triangular pyramid. Then when it's asked you to name the bases, faces, edges, and vertices, you're doing the same thing. You have your faces / bases because DEF could be the base, and then going the faces, even though remember you can't see it, there is a triangle in the back. So you have these 3 triangles because they have to connect the three sides of the base. Then you have your edges, DE, EF, FG, GD, and DF right there. And then your vertices are the easiest. You just name the letters. This one, again, it has triangular faces. So if it has triangular faces, comes to a point, then you know that it's a pyramid. What kind of pyramid is it? It's a rectangular pyramid. Its base is specific because it's not a triangle. So when you identify the base, you can call it out specifically as being this rectangle right here. And then the faces are the triangles. You don't need to put this in there. And then your edges and your vertices. You just want to make sure you get them all. And if you notice when you do your edges, you know you have 4 on the bottom, and then you have 4 going around the side. So it's just 4 times 2 would get you your answer. If this was a prism, it would be 4 times 3 because there's 3 parts. There's a base, a body, and a base. So right here, there's a base, a body, and a base. So a bottom, a body, and a top. So knowing that I have 4 sides, I would do 4 times 3 to know that I'm going to have 12 edges. And then the vertices are easy to do. I have 4 on the bottom and 4 on the top. So I have 8. And my faces are my bases because I don't know on a rectangular prism which is the base. So there you go. It's a rectangular prism. And again, you don't need to call out the bases separate from the faces because, you know, bases are faces in a rectangular prism. Again, a rectangular prism, but this time it's asking you to find out what is skew. So what does skew mean? Skew means, if you refer to your book on page 558, it tells you that skew lines are lines that are neither intersecting or parallel. So it has a diagonal that's connecting Q to W. So it's asking you to name all the segments that are skew to QW, meaning it can't touch those vertices and it can't be parallel. So skew lines would be like RS. It's not parallel to it and it's not touching it. UX is skew to it. It's not parallel and it's not touching it. TX is skew to it. UV is skew to it. VW is skew to it, and RV is skew to it. What you can't say is that RQ. RQ is not skew because it's intersecting right here. You couldn't say SW because it's intersecting right here. You could not say XW because it's intersecting. So you can say any other letter as long as you don't say the Q, you don't connect it with Q and W when it's diagonal. Now the thing is when you would have gotten tested on this, I would have asked you who is skew to RS because I think it's a little bit harder problem because remember, skew cannot be parallel. So you cannot say, so if I said who is skew to RS, I could say TX is skew because it's not intersecting in parallel. I could say QU is skew because it's not intersecting or parallel. I could say UV is skew, and I can say XW is skew. What I cannot say is QT because QT is parallel to RS. I can't say UX. It too is parallel. I want you to think about gymnastics in a parallel bars. That's parallel to RS. I definitely can't say SW because it's intersecting, and I can't say RV because it's intersecting. So hopefully you have a better understanding of what it means to be skew. Again, they did a diagonal. So who is skew to AG? DC is skew to it. I know it looks like it's intersecting, but it's not. That diagonal is going through the center of the shape. It's not going through this line. So DC is skew, BC is skew, EF is skew, EH is skew. What's not skew is HG is not skew. FG is not skew. AB is not, and DA is not skew. So here's answers of what is skew. So I would like to put what is not skew so you have an idea. So AB is not skew because it's intersecting. AD is not skew because it's intersecting with A. HG is not skew because it's intersecting. And GF is not skew because it's intersecting. So here we have an architect's sketch shows the plans for a new office building. So I want you to really want to look at that. This is isometric paper to give you that three-dimensional look. So I want you to think about how this is built. Sometimes it helps to draw the lines so you can see how it goes up. See how it's like 2 levels going up. And then what happens is, like, so you climb up 2 levels and then you run over to the next, and that one's straight, that's flat. And then you go up 1 more level. Okay, so you can kind of see that it's 3 floors. Okay, that's the top view and that's the side view. I'm going to come back to this picture. I'm going to show you the question first. So the question says, find the area of the ground floor if each unit on the drawing represents 55 feet. So let's go back. So each unit represents 55 feet. So each unit represents 55 feet. So what you want to do is you want to find the area. So I have a 1, 2, 3, 4, 5, 6 units by 1, 2, 3, 4, 5 units. Okay? So think about what that's going to be. This one is 1, 2, 3, 6 units. So if you look at this, I think some of you, what you would have done is 6 times 5 times 55, but you can't do that. You have to remember that each unit is 55. So it's 55 6 times, so times 55, and 55 5 times. So 5 times 55 like that. Then you put them together. So it looks like this. 330 feet by 275 feet. So that's the actual dimensions. So length times width would be 330 times 275, or 90,750 square feet on the area of the ground floor. So again, I want to look back at that picture. 6 times 55, 5 times 55, and then to find the area of the ground floor, it's just length times width. So that's where they're getting those numbers from. Okay. The next question says, how many floors are in the office building if each floor is 12 feet high and the drawing represents each unit is 40 feet? So you're looking at how many floors are in the office building if each floor is 12 feet high, and assume that each unit in the drawing represents 40 feet. So if you remember, the bottom area, if you see from the side view, the height of the building is 3 units. Think about that. So the height is 3. Each floor is 12 feet high. And each single unit of the 3 is 40 feet. Okay? So you have 40, 40, and 40. That makes 120 feet high. That's the total height. I go back and show you the picture right here. 40, 40, 40, like that, okay? So that's where they're getting 120 is your height. The question is, how many floors are in the office building if each floor is 12 feet high? So you just want to figure out how many 12s are in 120, 10 floors. So again, remember that picture, it's 3 units high. Each unit represents 40. That's 420. And then I want to know if so it's 120 feet from the bottom of base of the building to the top of the building. And each floor is 12 feet. So I need to know how many 12s are in 120 to figure out 10 floors. So we're gonna do it again. Same picture. So again, it's a 6 by 5 and it's 3 floors high. This time it's gonna ask you, it's gonna say, oh, each one represents 75 feet. So that's when you're gonna do 6 times 75 and then 5 times 75. Once you get those, you're gonna multiply those together and get your answer. This one, remember, it's 3 floors at 45 for each unit. Get your answer, and then you're gonna divide by 15. Whoops, 168,750 feet squared. And this one is 9 floors. There you go. So that's your basic understanding. Hopefully you can recall that basically we're looking at prisms and pyramids. Both are polyhedrons. Those are closed figures made up of planes, no curved edges. So we're talking primarily about polyhedrons right now. Eventually our curved surface figures will come into play. Good luck.